Hello, this is Module 1, Cosmic Introduction, Why and When Software Sizing. My name is Sylvie Trudel, and I'm glad to introduce you to the Cosmic method today. In this Module 1, you will learn benefits of using software functional size, when to measure or estimate software functional size, the relative cost of software measurement. We have also topics in other modules, like Module 2, Cosmic Key Concepts and Definition, Module 3, Management Information System Case Study Overview, Module 4, Real-Time Software Case Study Overview, Module 5, Cosmic Non-Functional Requirements, Module 6, Early Sizing Overview, and Module 7, the Estimation Process. Let's look at few key performance indicators, such as the scope, the delivery rate, and the effort or the cost we derive from it. Then very often organizations, when they deliver 100% of the defined scope on the planned date with the budgeted cost, they believe they have an efficient software process. Well, actually, they may have an effective estimation process. But if you want to know if your software performance is efficient, we have to compare the scope and the cost or effort to derive a unit cost and the scope with the delivery date. So we have an indicator called the delivery rate. Now, those two together are often referred to as productivity or velocity if you're in an agile world. And the Cosmic method does measure the scope size. So why sizing a software project is important? Then we want to know how big it is right up front. And we can confirm that size also throughout the project and at the end. And the benefits we have from these as the first one is, of course, we get to know the productivity of our software process, not of individual, but really the software process. And once we know that productivity, we can use the value to estimate our next projects. We can also use the values for benchmarking, whether external benchmarking or internal benchmarking. External is when you compare the productivity of your software process with the software process of other organizations in the same business domain or developing using the same technologies. And the internal benchmarking is when you compare, let's say, software process productivity in between business units, or also if you made a lot of change in your software process recently. Suppose you went from traditional to agile or from agile to DevOps, then you want to know what's the impact on the productivity. And that's internal benchmarking. There's also governance that can be done, whether you want to monitor the relative cost of annual software maintenance or the performance of suppliers to which you subcontract software development. And also for quality reasons, because while measuring the software size, we're using the requirements information that is available. And whenever the requirements documents are unclear, incomplete, they could be ambiguous in some point, then by measuring them, it's like doing some form of peer reviews on the requirements, and it will show up all the defects that may have in those requirements. So while you're writing them, it's a good idea to measure the functional size. But in order to obtain these benefits, we need objectivity, repeatability, and reproducibility. So how do we measure size independently from the technology? Well, the solution is to use an ISO standard. In this case, the ISO 19761 standard, which is also known as the COSMIC method. Now let's look at the COSMIC method. Where does that come from? Well, it's a second generation of functional size measurement method. It can be used to measure management information system, real-time software, mobile app, cloud app, service or microservice, data warehouse, agile projects, DevOps delivery rate, and also artificial intelligence module. It is actually translated in 12 languages, and all COSMIC documentation is available for free on the COSMIC website, which is cosmic-sizing.org. So yes, COSMIC is a not-for-profit organization, and all its work is based on volunteer work from researchers and practitioners throughout the world. The unit of measurement of the method is the cosmic function point, or CFP. Now, if we look at productivity of software project, research has shown that there is a strong correlation between size and effort. There is also a strong correlation between size and time elapsed, or project duration. Now, with the project data, we can derive the unit cost, which is the ratio of effort over size, or hours per cosmic function points. We can also have it in currency, let's say dollars or euro or British pound, or the Chinese yuan or Japanese yen, or any other currency you have. And it will be helpful, let's say, to monitor your costs from suppliers. And there's the productivity which can be expressed in terms of size over effort or cosmic function point per staff month. However, staff months may not be easy to standardize because it varies a lot from one organization to another. And the delivery rate is the size over time. So it can be expressed as cosmic function points per month, the calendar month, and also in cosmic function point per sprint, as long as your sprint all have the same duration. Let's say in agile, with the agile methods, for example. But even in DevOps, you could have the cosmic function point per calendar month, because you're delivering typically every day or quite often. And then within a month, whatever has been delivered, productivity can be measured from that. For estimation, let's take a very simple example. Here we have 5 projects, A, B, C, D, E, with size and effort. Now, if we take these data and draw a simple graph of linear regression, Excel does that in just a couple of clicks. Well, we obtain this line, this distribution of data of size and effort. And that's our equation. So effort is equal to 4.04 times the cosmic size plus 112 hours. And in this case, it has a strong correlation. I've been a practitioner of COSMIC for several decades in the industry. And within an organization, even though different teams are applying the same software process, we obtain that type of results, meaning a very high correlation. Now, there's always an interval, like the confidence interval for your estimation, but what is easy to use is the standard error that can be also quite easily calculated with spreadsheet tool like Microsoft Excel. Now, we have an equation, we have the standard error, so that estimation model, you fill in the size, it's going to give you an effort interval. You still have to estimate the risk. Not that we need to add a lot of effort for the risk, because those projects in the data set that was used to produce the estimation model, they did include risk mitigation effort. So what we need to figure out is our next project, is it way more risky than the ones in our sample, or is it much less risky than the one in the sample? And then we can adjust the effort accordingly. There could be also other costs that need to be added, such as, let's say, hosting of a web application with a provider. Well, there will be fees from that provider, and this will need to be added to the estimated cost. In terms of governance, we may want to monitor project velocity in COSMIC function point per sprint, for which research has shown to be a much better predictor of scope to be delivered than I would say, the unfamous user story points, which will have too much variance in the effort estimated per user story points. But it's not the case with COSMIC. It's much less variance, much more precise. We can also monitor the relative maintenance cost, let's say in dollar per COSMIC function point for bug fixing or software enhancements, and also monitor supplier productivity in hours per COSMIC function point or dollar per COSMIC function point. In a nutshell, this is an overview of the method. So let's say you have a software system. That software system has a list of several functional processes. On the front-end side, there's a boundary between the functional users and the software system. Those users may be human users, other software, or engineered device. On the back-end side, there's data in the persistent storage. Now, between the users and the software system, you can go through or not the I/O hardware. But whenever data comes in from a functional user, it's called the entry data movement. From the functional process to the user, it's an exit data movement. From persistent storage, it's a read data movement, and to the persistent storage, it's a write. So what is a COSMIC function point? Well, it's a data movement because software is manipulating data. So data comes in or out, we read it or we write it, and that's how we measure. Now, when should we measure? Well, suppose a simple software lifecycle, and you have, let's say, a couple of projects that have been closed. The actual COSMIC size can be confirmed at the end of the project. So if you want to build up your estimation model, you will need data from recent past projects. From this data, you will have the effort, the duration, and the size. And from these data, we can derive a baseline unit cost, which then feeds preliminary estimation for the next project. Now, preliminary estimation is usually done when software detailed requirements are not yet written. We only have preliminary analysis that contains a list of needs or high-level modules. And at that point, we cannot measure the software size per se, but we can estimate the COSMIC size. And that estimation of the COSMIC size will also feed the preliminary estimation. Now, once we start the project execution and we have functional processes description in the functional user requirements, whether it's in form of use cases, user stories, or change requests for maintenance, then we have a cosmic size, which include the planned one at first, plus the change requests that may happen during the course of the development phase or project execution, but we monitor that size throughout the project. So if you're in the agile mode, well, you can confirm the actual size at the end of every sprint with what's been done according to the done definition. So we know exactly which functionality have been delivered. We can confirm its size. It really doesn't take long, just a few minutes, and it's done. And that's how your model here, baseline unit cost, will again feed your preliminary estimation in the next project. When you do have some project for which you had the estimated size very early in the software lifecycle, and you have the actual size at the end and the new baseline unit cost, we can use what we call the scaling factor that will help to do better estimate for the next projects. Now, what's the relative cost of software measurement like? There are several factors that may influence the cost of COSMIC manual measurement. Well, first of all is the measurer experience. The more experienced the person is, the faster it is to do the measurement. There's also quality of functional requirements documentation. If it's non-existent, well, it's maybe a little bit hard to measure. It's not impossible. We can measure from code. We can measure from user interface, from test reports. But if you have good and clear documentation, my own experience was that I could measure at the speed I was reading it, the good ones. And you need also support from the development or maintenance team, because when there are ambiguities in the software requirements, then it's good to have the functional analyst close by so we can ask him or her the questions about how the software is supposed to work. And there's also an economy of scale on project size, because when we measure, we often read, let's say, the architecture document and general description of the software document to understand what the software does. And those type of document, their number of pages in a given organization is often the same whether the software is a small one or a big one. So basically, those are the main factors. There are also several tools that now become available to automate the software sizing. And this could, of course, accelerate the measurement, but they may not be as precise as a human measurer for now. So there's a larger variance of results. Nonetheless, measuring the software size, my own data is, it varies between 1 minute per cosmic function point to, I'd say, 2.5 minutes, the data I've collected while measuring in organization that I did not even know the business domain before I started digging into the documentation they had on their software project. Well, it's 2.5 minutes per cosmic function point. What's the average of a project? Let's say in banking and insurance, I've measured that an average project would vary between 100 and 300 cosmic function point. Sometimes they are like super huge project. The biggest I've seen was around 1200 cosmic function point. But if a project is 300 cosmic function point, well, it's between 300 minutes and 600 minutes typically to measure. So 600 minutes, it's 10 hours, it's a day and a half. But how much it costs to develop? Well, if you look at the productivity database that are available, it's roughly 10 hours per cosmic function points. So if it takes 10 hours to do the software development and only 1 to 2 minutes to do the measurement, well, it may very well worth it. So for further information, please refer to the COSMIC website for detailed rules, exception, domain-specific tips. There's the measurement manual, version 5, of course, but also a bunch of guidelines like business application guideline, real-time software, data warehouse, big data, SOA application, and case study. And feel free to go on the site and download whichever document you like. Thank you.